Hi class, welcome to the final lesson of Unit 1. In this lesson, we'll explore physical and chemical changes in matter. We'll be able to distinguish physical changes from chemical changes, and you should be able to list the 5 evidences of a chemical change. Physical and chemical changes is very closely related to physical and chemical properties of matter. We observe physical properties of matter without changing its identity. And we observe chemical changes by reacting the matter and changing the bonding, which therefore changes the formula, the name, and the properties of matter. The first type of change we're going to look at is a physical change. Physical changes involve a rearrangement of particles, but they do not involve the creating or breaking of any bonds. So the formulas, names, and properties of the substance don't change. Instead, the substances simply rearrange. One of the most common physical changes of matter are changes in state. Like when we melt chocolate, we go from a solid where the particles are very close together to a liquid where the particles are less close together. Other examples of physical changes can include dissolving in water. When we dissolve a substance in water, we still have that substance in water. So look here where we're dissolving sugar in water. The sugar goes and it spreads out within the water until it is completely surrounded by water, but we still have distinct particles of sugar and water. There's no bond being created. Physical changes are easy to undo because no bonds were created or destroyed. We do not make new substances, and the substances in this new physical arrangement still maintain their original properties. So sugar is still sweet, and the water is still wet when we make sugar water. During a chemical change, bonds are created or destroyed. A chemical will react. When bonds are created or formed, the formula changes, the name changes, and the properties change. Let's look at this example in the formation of water. When we make water, we begin with the reactants hydrogen. Hydrogen is a highly flammable gas. And we add in the reactant oxygen, another flammable gas. And these go and we have the bonds break between our diatomic elements and they create new particles of water. Water is a liquid at room temperature and it actually puts out fires. So notice that when you undergo a chemical change, not only does the name change, hydrogen and oxygen form water, but so do the properties. In this particle diagram to your right, you can see another example of a chemical change. Once these particles collide, a bond is broken where this red particle forms a new bond with a white particle. So you can see that we begin with 2 white particles and 2 compounds of the green and red particles, and we end up with 2 particles that have 1 white and 1 red, and 2 particles that have 1 green and 2 reds. Notice that it's important to remember that during any chemical reaction, matter or atoms cannot be created or destroyed. They're just simply rearranged by forming and breaking bonds. What we know is that during chemical changes, bonds are either broken or formed. But the problem is we cannot see atoms. So if we cannot see atoms and their bonds, we cannot know if a formula changed, a name changed, or the properties changed. So instead we must look for clues that indicate a change in property. There are 5 major evidences of a chemical reaction. The first evidence is a change in color. You can see here that the Statue of Liberty, which is made of copper, the same metal as a penny, has changed color as it reacted with the air. Cooking food is also a chemical change that is often accompanied by a color change. You know you've cooked your food too much if it has changed color and turned black because you've burned it. Another indicator of a chemical change is a change in odor. You know food has gone bad. It has changed from nutritive molecules to rotten ones when it has a change in odor. Another indicator of a chemical change is the formation of gas. In chemistry, this is known as effervescence. When yeast undergo the chemical reaction of cellular respiration, they produce carbon dioxide gas bubbles. This allows yeast to make bread rise. It also allows yeast to be used in the fermentation process where you change sugar into alcohol. The fourth indicator of a chemical change is the formation of a precipitate. A precipitate forms when two liquids are mixed together and a solid forms. It is called a precipitate because, given time, the solid will fall to the bottom of the container, just like rain falls from the sky. The final indicator of a chemical change is the production of heat or light. When chemical reactions give off heat, they are said to be exothermic. And when they absorb heat, they are said to be endothermic. We'll learn more about this in unit number 2. Burning is an example of a chemical reaction that produces both heat and light. Since there's no way to see atoms or the bonds that are being made or broken during a chemical reaction, there is no definitive way to know that you've created a new substance without extensive laboratory evidence proving that the properties such as density, combustibility, and magnetism of the substance have indeed changed. But these are still good indicators that a change most likely occurred. Let's look at this Regent sample question. In this diagram, we're looking for a physical change. Physical change means that the bond between the white and black circle is not broken and no new bond is created. These particles will simply be rearranged. So the image that shows a rearrangement of these particles is choice 1. This concludes Lesson 10 of Unit 1. This is the final lesson of the unit, so please make sure that you study. A review sheet has been provided for you, and your test will be soon. Good luck, and I'll see you in class soon.